There's a lot out there about climate and weather and what's causing changes in climate.
Yes.
So I got somebody who can tell us about this.
Oh, good.
There's a man, and he is right here. Steve Soder. Steven, welcome to StarTalk.
Thank you. Nice to be here.
Yeah. He just walked down the stairs from his office to my office.
That's one of the benefits of working in this building, I guess.
So, Steven, we've known each other for now, I guess, 30 years or so, some length of time such as that. And you were trained as a planetary scientist at Cornell? Is that a fair characterization?
Yes.
And you strongly overlapped with Carl Sagan there.
Yes.
And I'm not done here. In 1980, you co-wrote the original Cosmos with Carl Sagan and Ann Druyan.
That's right.
In your later years now, you've decided to take on climate. And you're writing this huge tome on climate. Remind me the title of this?
It's called 4 Billion Years of Climate Change, What the Past Tells Us About Global Warming.
Right now, I want to put on the books an accurate and clear description and understanding of the Milankovitch cycles. Let's start with just what we do know, all right? Mm-hmm.
Well, the Earth's axis is presently tilted at about 23.5 degrees from the axis of its orbit.
Okay.
And when it's tilted most toward the sun in the northern hemisphere, that's what we call northern summer.
Okay.
And 6 months later, the northern hemisphere is tilted most away from the sun, and that's what we call northern winter. The seasons in the southern hemisphere are the opposite. Because the tilt of the axis is what makes the seasons, and because there are astronomical forces that change the tilt of the axis and its orientation over time, the result is climate change. There's 3 cycles that affect the Earth's axis, and they're called the Milankovitch cycles after the man who investigated and calculated them correctly for the first time, whose name was Milankovitch. He was a Serbian applied mathematician and civil engineer. He did this work starting in the 1920s.
Oh, so it's recent. I mean, recent as in the 20th century, yeah.
People began thinking about how astronomical changes could be responsible for the ice ages long before then, but they didn't really have the details right. He got it right.
So the ice ages were a point of suspicion for historians, why we would go in and out of ice ages without any obvious forcing.
Yes. Mm-hmm. People wonder what was the cause of the ice ages. Right. Could it be changes in the atmosphere of the Earth? Could it be astronomical forces acting on the Earth? Mm-hmm. The ice age cycles are, the pacemaker of those are these astronomical cycles that were investigated by Milankovitch. So there's the change in the tilt, which is called the obliquity. The tilt of the axis, which is now 23.5 degrees, that wobbles, that goes through an oscillation of about a degree one way to 23.5 degrees. It goes to 24.5 degrees and to 22.5 degrees, back and forth slowly. There's the change in the direction of the axis in space, which has a 26,000-year period. That's called precession.
Mm-hmm. So while we're spinning, it will
exactly
wobble like that.
Wobble like that. And the period of that wobble is about 26,000 years with respect to the stars. And the third one is there's a change in the shape of the orbit of the Earth. The orbit of the Earth and of the other planets is not perfectly circular. It's elliptical. It's a distorted circle. And the sun is not in the center of that ellipse. It's off from the center. So at one point in the orbit, called perihelion, the Earth is closest to the sun. 6 months later, it's at the opposite end of the orbit. It's farthest from the sun.
In fact, you know what month we're closest?
I'm going to say winter, January. January.
Well, January, yeah. It's the opposite of what many people think.
Right.
Eccentricity, the deviation from being a circular orbit, that itself changes over time due to tugs by the planets, mainly Jupiter and Venus, on the Earth's orbit. And so the eccentricity goes through slow changes with a period of about 100,000 years and another longer period of about 400,000 years. So you add all of this complexity together, and you can calculate how it affects the strength of sunlight across the seasons and across the latitudes of the Earth over time. And you can calculate it pretty exactly because it's just celestial mechanics. It's Newtonian physics that has been perfected. You can calculate it for millions of years into the past and project it millions of years into the future. And this is the pacemaker of the cycles of the ice ages.
That makes sense, because if there were ice ages in the past, you would want to know when's the next ice age coming.
Yes.
So that you could buy a coat, you know.
Prep for it.
Yeah,
Yes.
yeah.
Okay.
So we have geological records now that in the last million years, there have been about 10 major ice age cycles going from ice ages to warm interglacial periods. We're in one of those now.
Has Earth ever been totally covered in ice?
Yes, but a long time ago, about 600 million years ago was the last time that happened.
Okay.
And about 2.5 billion years ago, it happened before. Usually there are...
Because I've heard something called ice ball Earth.
Snowball Earth.
Snowball Earth.
Yeah.
Snowball Earth.
Yeah. It was discovered that there were glacial features in the geological record of the Earth from places that had been near the equator, and that could be dated. And that showed that the Earth was covered pretty much from pole to pole a couple times in its
And
long
continental
geological
drift doesn't
history.
confound your reading?
No, you
of-
take that into consideration. You know pretty much where the continents were.
Right, because if something had ice at a higher latitude
and then
drifted down,
the landmass
it
moved.
could fool you.
That's right. But what's been shown is that some of these glacial features were near the equator at the time when they were deposited. Since the Earth was entirely covered with ice, it was reflecting a lot more sunlight. And the question arose, how did it get out of that state? How could it ever thaw?
Right.
And the reason probably is that volcanic activity was continuing. That didn't care whether there was ice cover over the Earth or not. And it was pumping carbon dioxide into the atmosphere, which is a greenhouse gas. Normally, carbon dioxide is slowly removed by being dissolved in the ocean and deposited as limestone. But since the oceans
were
frozen,
there's no place to absorb.
It just builds in the
It just
atmosphere,
built up and up and up until you had a super runaway greenhouse effect, which became hot enough to melt the Earth, and that freed the Earth from the grip of the snowball.
But back up for a moment. So what you're describing is as more and more ice builds,
Yeah.
more sunlight is reflected,
Yes.
making Earth even colder.
Right.
Positive
Growing-
feedback.
It's a positive feedback loop.
Yes.
Creating more ice,
Yeah.
more reflectivity,
Yeah.
and there's no way out of that.
It seemed that there was no way out of it, except that the Earth is still pumping out carbon dioxide from volcanoes.
But I thought we were in the Goldilocks zone,
in terms of,
temperature of the Earth and our distance to the sun.
yes, but
So how could you sustain a whole planet of ice?
what determines the temperature of the Earth is not just the amount of sunlight reaching it, but the amount that's trapped in the atmosphere by the greenhouse effect. And that has varied over time because there's been changes in volcanic activity and in the rate of uptake of carbon dioxide by weathering of rocks and deposition of the carbon in the oceans. The volcanic sources and the sinks, which are the weathering, those are separate from each other. They don't have to be exactly in balance.
You said 10 ice ages in the last million years.
Yes.
So if I do the math, that's one full cycle every 100,000 years.
Yes, approximately.
Approximately.
Yes.
Okay.
Yes.
So if we exited an ice age, 20,000 years ago, perhaps?
We began to come out of it 20,000 years ago. yeah.
Okay. So we're in an inter-ice age period
Yeah,
right now.
it's called an interglacial.
Interglacial.
Yeah.
And is that good or bad?
Well, for us, it's good because it's a stable climate. During the Ice Age, the climate is more unstable than it is during interglacial periods. It fluctuates.
So we built all of civilization as we know it in a relatively stable interglacial period.
That's correct.
Which is a little delusional because we think that's just Earth, but it's not. It's just a temporary state.
Yes. It's not knowing how long this interglacial period would continue if we were not already interfering with the atmosphere, which we are. But it's a good estimate is it would go for another 8,000 years or so before we went into the next ice age.
So what's wrong with global warming if it'll delay the next ice age?
Because it's too much of a good thing. If there was no carbon dioxide greenhouse effect, the Earth would be frozen pole to pole like it was during
Right now,
snowball Earth.
that would be.
Right. So the natural greenhouse is a good thing, but we have increased the amount of carbon dioxide in the atmosphere from its natural amount by about 50%. And because carbon dioxide is the principal climate regulating gas in the atmosphere, that's a big deal.
So, and when you say this 50% number that you, and many will say, how do you know that it's us that's doing that? What makes you say that we have made this 50% increase in the greenhouse gas?
As opposed to natural processes.
As opposed to a natural process. What, I mean, why would you say we did it?
Well, first of all, you can tell from the isotopes of the carbon in carbon dioxide that it's not coming from a volcanic source. It's coming from fossil fuels. That fossil fuels have, the carbon in fossil fuels has a different isotopic weight than the carbon.
So different amount of carbon-14?
No, it's carbon-13 actually.
Carbon-13?
Yeah, normal carbon
we hardly ever hear carbon-13.
Yeah,
Exactly.
the common carbon is carbon-12. Carbon-13 has an extra neutron that makes it a little heavier. And the amount of carbon-13 is different in volcanic gases compared to fossil fuels. So you can tell, you can measure what's being put into the atmosphere, and it has the signature, it has the fingerprint of fossil fuels. And the other thing is we can calculate the amount of emissions from all of the industrial activity, and we can measure the buildup of carbon dioxide that is observed in the atmosphere, and they agree.
Got you. So basically, we know how much we're pumping out. That's measurable.
Yes.
We're able to measure the isotopes so that matches that signature.
Yes.
And if we compare the volumes of the two, then we're the culprit.
Yes.
Okay.
Yes.
Okay. All right. That makes
No way out of that.
There's no way out of
Right.
it. Like, yeah.
And we're putting the carbon dioxide in the atmosphere about 40 times faster than natural processes do it. The natural processes can remove the carbon dioxide at very slowly over thousands of years, but we are pushing it 40 times faster than the Earth can accommodate it. So it's building up in the atmosphere and in the oceans at a very rapid rate compared to the rates at which it normally changes over geological time. This is a real shock to the system.
Have we put enough carbon in the atmosphere that if another Milankovitch cycle were to come, it wouldn't be an ice age?
That's exactly right. We have prevented the next ice age from happening.
Oh,
we're going to skip the next 100,000 years of normal changes in the climate due to the Milankovitch cycles.
I didn't want that anyway. I don't be running around in bearskin loincloth.
No, we don't want an ice age. But the problem is, it's going to overshoot by far what would be required to prevent an ice age. Is going to become
we're
worse.
going to go too far in the opposite
Exactly.
direction.
We're going to. What we're doing is we're messing with what would otherwise be a stable climate for the next few thousand years,
Right.
and we're pushing it into a state that the Earth has not seen in many millions of years.
So another thing that just dawned on me from what your description of snowball Earth, albedo of the ice.
The reflectivity.
The reflectivity, is that still at play from the glaciers that we have on Earth now? And as they recede, will that speed up climate change because we're losing great glaciers?
The inverse effect of the other.
Yes, it's a positive feedback. The warmer it gets, the more ice melts. The darker the Earth gets, the more
warmer it gets.
Exactly. That's a positive feedback.
Jesus.
The sea ice in the Arctic Ocean is retreating rapidly. You can observe that with satellites over decades. It's melting. And so that's changing the reflectivity, so it means that the Arctic is warming actually about twice as fast as the Earth as a whole.
So, Steve, right now, Antarctica is still covered in ice.
Yes.
And so is Greenland.
Yes.
Okay. So might we reach the opposite of snowball Earth, where there's a no-snow Earth?
Yes, that's happened, and that's actually the majority of Earth's history. There was no ice, no ice caps on the Earth.
When that happens, the water level, because I did a calculation, that it would rise to the level of the Statue of Liberty's left elbow.
Yeah, if you melted the ice, you'd get about 130 meters of sea level rise, more than 400 feet.
Yeah. And that's when Kevin Costner is our leader.
Yeah, but it's very slow. It takes a long time to melt all that ice.
All right. Well, Steve, thank you.
Sure.
For clarifying this. And this book, when do you expect to finish it?
Hopefully within this year.
This year, within 2025.
I hope so. Yeah.
Okay. And you've been working on it like for a decade.
Well,
more.
yeah.
Well, we are talking 4 billion years. Cut the man a break.
All right, Steven Soder, thanks for joining us on
Thank you.
StarTalk. Chuck, always good to have you on the Explainer.
Always a pleasure.
Can I get him to my moon back, please?
Oh, man.
Thank you. This has been another StarTalk Explainer. I'm Neil deGrasse Tyson, your personal astrophysicist. You keep looking up.
New findings may be shaking up everything we thought we knew. Data suggests dark energy might be weakening, meaning the universe's expansion could actually be slowing down. If true, it would challenge one of the biggest assumptions in modern physics. But before we rewrite the textbooks, we need clarity. That's exactly why StarTalk continues to partner with Ground News. They built an app and website that helps us separate speculation from science. With one swipe, we can find original research and highly factual sources covering the most complex breakthroughs in cosmology. They were actually founded by a former NASA engineer with the same level of precision you'd expect for space missions. But the best part? Ground News isn't some new tool to learn. They're a smarter, better version of how you're already staying informed. So follow every major development from dark energy to deep space, with interest pages tailored to the topics you care about most. We're giving our viewers 40% off the same unlimited access Vantage plan we use. Just go to groundnews.startalk or scan this QR code to bring the cost of context and clarity down to $5 a month.
Get ready to leave the world behind, because on Paramount Plus, Star Trek Strange New Worlds is back for an all-new season of genre-bending adventures, romance, mystery, action, space zombies, special guests. This show is going where no show has gone before. One show, infinite adventures. Don't miss the new season of Star Trek Strange New Worlds, premiering July 17th with new episodes on Thursdays only on Paramount Plus.